So page 294, we're doing number 3. That's what you want to say? So this is section... They want me to find all kinds of things here. And I'll do that. By the way, one thing that makes this much more fun is if we draw a picture the way that Gauss did. We're going to call this the real number line, and I'm going to call this the imaginary number line. Okay? By the way, what I'm doing here with the graph is not in your book. You won't see it. Okay? It's a little beyond college algebra, but I think it may help you understand what's going on. Okay? So the way that Gauss did this, like when he wanted to represent W, I'll do W in this kind of reddish color here. He would plot -1 as the real part and +2 as the imaginary part. And so for those of you that have studied physics or whatever, you can almost think of that vector, that arrow being the representing -1 plus 2i. Because it's 1 on the real plane and on the real number line and 2 in the imaginary number line. And similarly, this z equals I, I'll do in kind of a dark blue. Well, that's 0 on the real number line and 1 on the imaginary number line, so it's right here. It's that point right there, right? 0, 1. Okay? So they asked me to do all kinds of things. They asked me to find z plus w. Well, okay, so I have to do I plus -1 plus 2i, right? That's what z plus w is. And you can simplify it, and what do you get? Well, now you just have to follow your rules of algebra, right? We add the like terms. So what gets added? The i's, right? So I have I plus 2i gives me what? 3i, okay? And so I get that z plus w equals 3i. But like I said, if you want to have fun with that, what you do is, remember z is this blue one. If I take w and I kind of go tip to tail with it, right here, okay, then the sum z plus w equals, oh, I missed something. What happened to the -1? Whoa. 2i plus I is 3i, but what did I miss? The -1. So -1 plus 3i. Thank you. Anyways, on the picture, if you check out that sum there, that is -1 plus 3i. Kind of a cool little picture. Show of hands of people that have taken physics. Show of hands of people that will take physics. You guys raising your hands now? This arrow drawing stuff you're going to do all the time. You won't have eyes involved. But this idea of adding vectors. Vectors are, they have both a magnitude and a direction. And this is kind of a good warm-up for that. Okay? Now, you guys that asked the question, asked me to do number 3, didn't care so much about the picture. It was just like, hey, let's do the algebra. Okay? What else did we have to do? We had to do ZW. So that means multiply. So what do I get? Well, Z is I, and W is -1 plus 2I. So again, I have algebra rules. How do I multiply quantities like that? Well, I guess what we're going to do is we're going to distribute, right? Does this make sense so far? So let's see. What is -1 times I? Minus I. Plus, and 2i times I is 2i squared. But can I simplify? Well, I can, because what is I squared? That's the key fact, right? Is that I, being the square root of -1, this I squared can be replaced with negative 1. You guys with me? Okay. So, I want to finally write it in the form, the form we like for complex numbers is a plus bi. We always like to put the imaginary part second. And again, I don't know if you would know why that is if you hadn't ever seen what I'm drawing here, a picture. Okay? A picture. So let's see what we end up getting. We end up getting, let's see, negative 2 minus I. Negative 2 minus I. And I promise, this is the last time I'm going to graph something. Because I have to restrain myself, all right? Because it's not in your book. It's not really college algebra material, but I kind of feel like it should be, guys. Watch what happens when I graph this. So let's see, where do I go? Negative 2 on the real direction, so that's over here. And then I go where? Down 1, okay? And so that puts me right here. Now I'm going to draw the arrow. Okay, so that arrow is negative 2 minus I. All right. Now I want you to notice something about the pink arrow. Remember what the pink arrow was. The pink arrow was negative 1 plus 2I. And the blue arrow, do you notice anything? About those arrows? Again, this is beyond what we need to study, but I just think it's really cool that there's a nice fact that goes with this problem. Okay? Multiplying by I is a rotation by 90 degrees in the complex plane. The complex plane C. What's the complex plane? That's the guy where you make a real number line and an imaginary number line. I just think that's kind of cool. That's why I assigned problem 3. Because I thought, oh, if we actually draw the picture, we're going to see that the length didn't change at all when we multiplied by I. But it's a rotation. Now, so let's go right away. One of the things we have to find, it says, is Z bar. Now, what the heck does that mean? The conjugate. The conjugate. So if Z equals A plus BI, then Z bar equals what? Well, the conjugate means just change the sign of the imaginary part. Z bar is A what? Minus BI, okay? So here as an example, we have W is negative 1 plus 2I. So what is W bar? That's easy. All I have to do is change that plus to a minus. Okay? So the bar just says change the sign of the imaginary part. It's called a conjugate. All right? And you might say, well, why would we ever care about that? All right? Well, let me show you why. Because if I take a complex number like W and I multiply by W bar, something really nice happens. What? It's not that nice. But what I'm going to tell you is this will be real. This will be real. WW bar is going to be a real number. Let me prove it, at least let me demonstrate it for this example. So what do? Well, I need to do -1 plus 2i, that was W. And let me multiply by W bar, and that's -1 minus 2i. Okay? And so when I do these, how would you multiply these? Well, we have to do our algebra. What am I going to do? The FOIL, right? First, outer, inner, last. So let's see. I get -1 times -1 is 1. And then I get -1 times -2i. That gives me plus 2i. You guys follow? And then what do I get? Then I get minus 2i, and that's good, because remember I said this thing's going to be real. And then what's the last thing I get? Minus 4i squared. Minus 4i squared. So let's see what happens here. Well, I said it will be real, and that's because the 2i and the minus 2i are going to disappear. And then what else is going to happen? I squared is -1, so we're going to get 1 minus 4 times -1. That's 1 plus 4, which is 5. Okay? That's 5. And by the way, yeah, that's enough. That's enough. Too many by the ways is no fun. But over here, ZZ bar, that's a harder one. I apologize, but that was the first problem I assigned. The reason that's harder is because what does Z equal? I. So I guess the question is, do you know what Z bar would be? It's going to be minus I. Right. Because you could think of I as 0 plus I. And so this would be 0 minus I. Okay? So to get ZZ bar, I have to multiply I times -I. And that's -I squared, which is what? It's -1, right? So it equals, like you guys said, 1. Okay? I'm going to say a little bit more. Not only will this be real, it will also be positive. I don't know if you see why that is. It's because you're always going to get minus a negative number, and so you're always going to get a positive. And so one last thing I'll say is that the length of these arrows is given by the square root of ZZ bar. That's really kind of cool. So in other words, this example I did W, right? W was this pink one. The length of that thing is the square root of 5. And you could do that with the Pythagorean theorem. 1 squared plus 2 squared will be 1 plus 4 is 5. And take the square root, you get the square root of 5. Okay. Just as one further example, we want to talk about what we're doing right now, Z over W. Z over W is I over -1 plus 2i. And we said it's not simplified because you can't have a radical in the denominator. All right? So what am I going to multiply by to fix it? That's right. Negative 1 minus 2i. We multiply by w bar, the conjugate. I also have to multiply the top by negative 1 minus 2i, again, so that I fix it. Okay, so we work these out, and let's see what happens. We get, well, in the numerator, I guess I just have to distribute the I. So I'm going to get minus I minus 2I squared. Negative 1 times negative 1 is 1. Negative 1 times negative 2i plus 2i, but then I get minus 2i. You know, eventually, I'll forget about the outer and inner terms when I do a conjugate, because I know these are going to drop out. The only thing I have to worry about now is what happens at the end. So what do I write down at the end? Minus 4i squared. Very good. Okay? So now I'm going to simplify. The numerator is negative I minus 2 times negative 1. And the denominator, I would write 1 minus 4 times negative 1. So this equals negative I plus 2 over what? Over 5, okay? That's kind of nice. But again, I'd really like to write it in the form a plus bi. So I'm going to do that. I'm going to write that z over w is equal to, I guess I would write the real part first. What's the real part going to be? 2/5. And then maybe I would write minus 1/5 of I. That's how you could do the minus I over 5. And that would be my answer to this problem. Yeah, I'm glad you guessed that.